more about musical instruments, because these are the ones which are used to produce beautiful melodious sounds. So now, consider an example of a guitar. How does a guitar produce sound? So that is when you pluck the string of a guitar. When you pluck the string of a guitar, a vibration is created leading to sound. Taking the example of tabla, when we talk about tabla, we hit on the membrane of the tabla which causes vibration producing sound. So these are some daily life examples of how sound is produced. Talking about all these things, let's move to the next topic, which are characteristics or properties of a longitudinal wave. So we have frequency, wavelength and amplitude when we talk about a longitudinal wave. We have a longitudinal wave. In the longitudinal wave, wavelength can be defined as the distance between two consecutive crusts or two consecutive troughs is known as wavelength. So by this I mean we have hills and valleys, as I told you. So the distance between the top of two hills is called as a crust, and or you can also say the distance between the two troughs or the valleys is called as the trough. So now we have understood what is wavelength. So wavelength is represented by the letter lambda. So lambda is a Greek letter and this is used to represent the wavelength. Understanding wavelength, let's move on to frequency. To understand frequency, it becomes very important for us that we understand the term oscillations, because frequency is defined as the number of oscillations per unit time. Now what are oscillations? So when we talk about a longitudinal wave, as I already told you, it has hills and valleys. When we consider one complete cycle of the longitudinal wave, that is starting from the hill, going to the valley and again coming back and ending at the hill. So basically it would have two crusts and one trough, or it would have two troughs and one crust. So this is one complete cycle which is known as one oscillation. Now when I have to define frequency, I would say the number of these oscillations per unit time. Say suppose I fix a time of 5 minutes. So when I'm fixing a time of 5 minutes, I would see how many such complete oscillations are passing through one particular point in that unit time, that is 5 minutes. So say suppose 20 oscillations have passed in that particular 5 minutes. So the frequency would be 20 divided by 5, that is 4. So this is how frequency can be calculated, and the SI unit for frequency is hertz. You can always calculate the frequency in terms of hertz, and it is represented by the letter nu. So nu is similar to V, but it is a little different, differently written from V. Now we have understood wavelength, frequency. Let's talk about amplitude. Amplitude is another very important characteristic of any sound wave. So now let's talk about a longitudinal wave, where again we have the crust and the trough. So amplitude is defined as the distance from the mean value to the maxima or the minima. So when I say maxima or minima, it's nothing but a crust or a trough. So amplitude is, you can also say, the height from the basic horizontal x-axis that we draw when we are drawing the wave. So this is how amplitude is